Some Joes never tire of watching an airplane land or take off, especially when the airplane is a beaut like the bomb-toting B-26 Marauder, and especially when the Joes are that airplane's ground crew. Understand, these men feel mighty possessive about that B-26 called Maisie. They're human. They seldom lose any sleep over an Army lecture or during it, but one lecture they took to heart concerned the terrific responsibility which rests on their GI shoulders. They saw damning proof of the percentage of airplane and engine failures resulting from faulty maintenance. They know, even without their pilot's frequent reminders, that only with proper servicing will an airplane do the job it's slated to do. If Maisie's not kept in perfect condition, she may fail her crew, may even kill them. Especially on the crew chief's mind, as he checks over his flight report, is one thought. A haphazard inspection is worse than no inspection at all. This thought will amount to his general orders during the 50-hour inspection he's getting set to pull. From the moment they start towing the airplane, this crew is careful to follow the book. There's a man stationed at each wingtip. They're towing slowly with a direct pull on the nose wheel, not turning it too sharply. And they're careful not to impose excess loads on the landing gear struts. A thorough 50-hour takes quite a bit of time well spent in spotting trouble before it can become serious. But to avoid grounding the airplane for too long at a stretch, the crew chief's covering it in sections. Today he's checking over the airplane in general, leaving till later inspection of the engines and propellers, ignition and electrical systems, fuel and oil systems, and landing gear and hydraulic system. Of course, all these inspections will be accomplished within the prescribed time limit. The job begins without delay. The de-icer boot brush is here grounded to a mooring ring. A ground stake or ground anchor would serve the same purpose, which is to discharge any static electricity that might have accumulated in the boots during flight. The brush is run along the full length of every boot before Maisie is refueled. At the nose wheel, the static ground is checked to see that it's securely attached and touching the ground. A pad slung over the de-icer boot protects it from damage, which would result if the heavy fuel hose were dragged across it. It's a lot easier to drape a pad over the edge than it is to repair or replace a chewed-up boot. Inserting the static discharge plug or fastening the clamp to the airplane serves to ground the nozzle and the mechanic, both of whom might otherwise be lost in an explosion caused by static electricity. Meanwhile, a thorough wash job along the fuselage, below and above the wings, and behind the ears. Dirt not only cuts down airplane performance, but might hide surface defects. The shock strut prefers a steam bath, but if that's out, they'll shine under a water hose and soap. After being washed free of dirt and grit, plexiglass is wiped with a soft cloth saturated in the proper cleaner, then dried with a dry cloth. All seams should be properly sealed, showing no signs of looseness or cracks. The main idea in cleaning plexiglass is to avoid excessive rubbing. Like a cat, it won't scratch as long as it's treated gently. This, of course, applies to both sides of all transparent surfaces about the airplane. When Maisie goes into action, every man on the crew needs clear visibility on every side. Up in GHQ, one of the men is starting to quiz the cockpit. These clips haven't ripped loose, have they? And the cushions themselves, any breaks or tears? In good condition all around? Now, what about the pilot's checklist? Is it up to date? All items clearly legible? The correct information set forth in red and black type? All okay on both sides? Then let's leave it where the pilot expects to find it. And the seat. Does the adjusting mechanism work properly? Up and down and back and forth. It works better when the tracks are kept greased with the lubricant specified in the TO. No cracks or breaks in the seat or its brackets. Every compartment in the airplane is thoroughly cleaned, not because company's coming, but because dust and dirt flying around loose are a definite hazard to the crew. Soundproofing should be intact, no cracks or breaks, securely attached to its brackets. Even the ashtrays are emptied as the airplane is tidied up so it'd pass inspection anywhere. And of course, eyes are open for stray tools or any other loose object which might cut loose and conk somebody during a maneuver. Water boy, One thermos bottle to be refilled and put back. On to the fire extinguisher. Is the safety wire seal intact, proving that it hasn't been used or tampered with? Is it securely fastened in its bracket? Does the date of the last weight test satisfy regulations? And the first aid kit, is its seal intact? If not, a red diagonal would go on Form 41B, and the medical department would replenish the kit. The shoulder straps are attached solidly. They have to be to protect the pilot in case of emergency, and they have to be in perfect condition to withstand the great strain which might be thrown on them. That goes for webbing, fixtures, and brackets. Naturally, the safety belt is just as important. Security of attachment is the familiar byword here. Also, condition of the belt and buckle. It should snap on securely. But in case he needs to, the pilot must be able to slip out quickly. A broken strand or any frayed spot in the webbing can mean a belt that's NG. The inspection must be minute if the name safety belt is to mean anything. The most recent weight test must have been performed within the prescribed time limit. Now for the hatch, which is opened up for the inspection of the hinges. This is another piece of emergency equipment which must be right on the ball should it be needed. Incidentally, leaning against the hatch is not recommended, as it might be sprung and so not go back into place. Is the emergency release handle secure and safetied? And those hatch hinges working smoothly? No breaks or cracks? Then you're clear to close the hatch. Of course, until it should be needed, the hatch must be locked positively by the latch pins. In the navigator's compartment, another hatch on the menu today. Does it swing freely? Are the brackets and locking devices secure and intact? Do they operate smoothly, or will the navigator have to resort to judo? Is the bonding tied down where it belongs? All hatches and emergency exits in the airplane rate this same type of inspection. Windows, too, must operate smoothly. A little grease in the tracks helps a lot and keeps them from balking like old-fashioned day coach jobs. Then there are a few more window checks. Do the latches operate properly? Are all seams closed up? Are the frames in good condition? Any dirt or scratches on the windows themselves? While a couple of men have been straightening out Maisie's internal affairs, the rest of the crew have been simultaneously continuing the inspection on the outside. They've got their procedure down pat, so that at each step of the way, each man knows what he's got to do to keep the job running along smoothly. A slip knot will do the trick on fastening that mooring rope. And it'll do again for tying it down to the mooring ring. In mooring an airplane, it's a good idea to provide sufficient slack to take up any sudden jolt. That's the idea. All cowling is removed from both engines for cleaning and inspection. To protect the small holes, Maisie's pitot tube gets covered. All inspection panels are removed for checking the internal structure of the wing and the actuating mechanisms of all movable surfaces. The cowling, like the oleo struts, goes in for a steam bath. When it's clean, it's inspected for cracks, chafing, loose rivets, insecure bonding, or any other damage which might have occurred. Each section submits to a close examination. In the cockpit, the crew chief's taking care of the paperwork, transferring data from Form 1A to 41B, and bringing his 41B right up to date. Keeping Maisie in flying shape is his main job, but it's also his responsibility to maintain her case history, so she'll get the right attention at all times. In inspecting the fuselage, one thing to look for is oil cans, like this one. Such a defect is marked with chalk for repairing later by the sheet metal crew. That's right, Sergeant. Enter it on your 41B so it won't be overlooked. Other things to hunt down are loose bolts or rivets, condition of the metal covering, cracks, loose structural members. And remember, structural trouble may be some distance from the indication, so if anything looks wrong, a thorough check is in order. Sharp bends are good breeding places for cracks in the skin, and so should be examined with special care. The same complete visual inspection is given to every surface of the airplane. The man on the wing who of course wears rubber-soled shoes, checks for loose rivets or bolts, elongated bolt holes, corrosion, breaks, and for skin ripples, which would betray loose ribs, broken rib members, or damaged gussets. And what about the de-icer boots? Any cuts, breaks, tears, or holes? Is the sealing strip secure? No? Okay, tighten down that screw. The boot is also examined for possible deterioration from oil or extreme climatic conditions. That's right, don't miss a trick. Is the sealing strip secure around the landing light compartment? Around the heating system air intake? Now, a sensitive ohmmeter and phenolic block are wired together in order to check the conductivity of the outer surfaces of the de-icer boots. This is done by holding the block against the boot in several places and observing the readings on the ohmmeter. This measures the resistance to the flow of current through the boot between two small contact points. Should the reading on the ohmmeter be too high, the boot would not conduct the static charge which might collect. This one's okay, but a faulty boot would get 2 coats of special cement. Meanwhile, the general visual inspection of the fuselage continues, along the sides, underneath, and on top. Not 1 square inch of the surface escapes the eagle eyes of the crew, for when an airplane's been used heavily, it can develop trouble anywhere. Paint's chipped off here. That means a check for structural trouble and a touch-up job later. Another place which rates an especially thorough inspection is the joint between the empennage and fuselage. Any sign of torn or loose covering? Any pulled rivets or elongated bolt holes? Cracks that may have been caused by excessive vibration? It's not too easy to navigate around this portion of the airplane, but that's no excuse for skimping on this highly important phase of the inspection. Both sides must be closely examined. The crew chief spotted a loose rivet, so he circles it and makes a note on his 41B. Loose rivets can generally be detected from the chipping of the paint around them. When the inspection of the exterior surfaces is complete, and before he goes any farther, the crew chief checks with the various members of his crew for any dope they've picked up, which should be entered on the 41B. Before going under the wing, let's look at a diagram showing its basic structure. The center wing, which is an integral part of the fuselage, consists of 2 spars and, under the outer wing skin, a corrugated inner skin for the top connecting surface of the spars. The wing is held to the center section by 4 hinge bolts, 2 at each spar. Both spars are further held by a number of splice bolts. Finger splice bolts tie the corrugated inner skin to the center section, and trim angle bolts further support the weight of the wing. These trim angle bolts can be inspected from the bomb bay to see that they're secure. Likewise, inspection can be made of the finger splice bolts. Are they tight at the butts? Are the self-locking nuts secure? The examination continues with a check for elongated bolt holes. After inspecting all of the bolts which he can reach, the mechanic moves on to check the bomb bay doors and their mechanical linkage for condition and operation. There's a hydraulic cylinder and actuating chain on each side of the forward bomb bay. His visual inspection revealed that the chain has accumulated dirt and grime, so he wipes it clean to ensure smooth operation. The clean chain is then greased with the lubricant specified by the TO for this job. When this has been done and everyone is clear of the doors, they'll be ready for an operational check. Okay, let's go. With 1 man stationed inside and 1 outside, the doors are closely watched as they shut. Does the linkage function smoothly, without a hitch or a falter? Are the doors traveling as they should? Does the hinge attachment work easily? In closed position, do they seal properly, flush with the fuselage and not sprung? As the doors open, the mechanics again ask themselves the same questions to see that no defect shows up which was not revealed during the closing. It takes a little time, But when Maisie's big moment arrives, these doors must draw back out of the way without the slightest suggestion of a hitch. One more item, the door hinges. Are the bolts tight and secure? No cracks in the brackets? All in good condition? Still in the bomb bay, he checks over the structural braces on the catwalk, paying special attention to the stress points where cracks are likely to develop. Outside, the crew chief's getting around to see that the inspection's moving according to schedule. He's particularly interested in the check of the tail heater pipe. A single crack or bullet hole would allow deadly carbon monoxide to leak into the heating system of the airplane. The pipe must be securely mounted and the clamps in good condition. All right. With a little cooperation on the push-pull rod in the navigator's compartment, he checks to see that the heat control, or spill valve, opens and closes as it should. Then he continues to inspect the system throughout. The defroster tube is worth more than a passing glance. Does the butterfly valve operate smoothly? What about the flexible tube covering? Any tears or rips? Has it started to fray? Any cracks in the welded joint? Is this valve okay? And the tube fixed to the wall below the joint, is it secure and in good condition? Nearby is the heat damper, which should operate easily. And then the mechanic moves on back through the airplane to inspect the rest of the heating and ventilating systems. The life raft doesn't see much service, fortunately. But when it's needed bad. So it must be inspected regularly to see that it's ready for the emergency it might be called upon to meet. The CO2 cylinder in particular. The safety wire on the check valve must be intact. But on the other hand, the safety must be off the handle. A thorough check is made to see that every prescribed item is present and in good condition. Look for all of them. Emergency rations, patching materials, paddles, first aid kit, water, sea anchor, and every single item prescribed in the latest regulations. Equipment changes from time to time. New items are frequently added or substituted for old ones. Know what should be included and see that it's all there and that it hasn't been damaged from shaking around. And before putting the raft back in its carrying case, be sure to check the top-off valve in each compartment to see that it's tight. This connection can be used for an external source to the de-icer distributor in the bomb bay. The oil separator is checked, and then the lines are inspected for leaks, security of attachment, and tightness of all fittings. The de-icer distributor motor. This, too, should be secure in its mount. To inspect it further, the cover must come off. How's the electrical connection to the armature unit? Brushes reveal any wear? Commutator showing any black streaks or any other sign of damage? It's cleaned with a rag, which has been saturated in unleaded gasoline. The cover is replaced in safety. In the aft bomb bay is the anti-icer reservoir. Is the cap securely attached? Inside, does it show any sign of rust or condensation? It's screwed on firmly. Is the reservoir nesting snugly in its straps? Are the brackets in good shape? Does the sight gauge show that it's full? The anti-icer pump, too, must be secure in its mount. The electrical connection is checked, likewise the lines, to see that they don't leak and haven't been shaken loose. The crew chief gets set to test the anti-icer while other mechanics, keeping clear of the props when the main switch is first turned on, check the line up to the slinger ring. All right, on with the alcohol pump switch and up with the rheostat. After a few seconds, fluid should be visible at the props. Okay, you can cut off the rheostat and the switch. Now to check the flight control surfaces, with the crew chief in the cockpit and men stationed outside to observe the response of the surfaces to the movement of the controls. Free and full movement is what they're checking for. Now a test for side shake and security of attachment. He also checks for fractured or broken ribs, for loose hinge bolts, worn bearings, or loose linkage. And what about the ailerons? Do they operate freely through their full range? Any side shake? The actuating mechanism is reached through an inspection panel for checking the adjustment of the stops and the pulleys, cables, hinges, and bonding. Just as on the elevators, the ribs are tested by depressing them from top and bottom, and the surface is examined for punctures or tears. Now to check the rudder. In the aft compartment, one man sees that the quadrant and rudder stops operate properly and that the stops are correctly adjusted. He also makes sure that everything's secure and that all bolts are safety. While he's watching the show from this position, another man's keeping an eye on the rudder itself to see that it travels freely and will not interfere with the elevator in any position. Grabbing it at the bottom and trying to shake it up and down, he tests for looseness or play in the bearings. Finally, he makes a close examination of the rudder's actuating mechanism. The crew chief now tests the trim tab controls, beginning with the elevator tab, while again, the men outside check for full and free movement. They also test for side shake and play. The rudder trim tab control, and in the aft compartment, the torque tubes are checked for operation and possible misalignment. Now the rudder trim tabs are observed in action. Do they move freely to both limits? Any excess up and down play? Is the linkage secure? Do the friction control blocks hold the proper tension on the torque tubes? Finally, the aileron trim tabs are given the same inspections. Do they operate freely? Is the actuating mechanism okay? Each tab on the airplane should move easily in each direction to the limit, where it is halted by a stop built into the cockpit control unit. Any side shake? Is the linkage properly safetied? Inspection of the wing flaps will complete the tour of the movable surfaces. How's the linkage? In good condition? Properly safetied? And the surface of the flap, any cracks or other damage? Experience has shown that the underside of the trailing edge is especially vulnerable to cracks, so it rates close attention. With the flap control in down position, the pressure in the system will lower the flaps for an operational test, while the men outside continue to check the linkage, fittings, and brackets for security and general condition. They look closely along the trailing edge of the wings and the leading edge of the flaps. Here again, past experience has taught that cracks are apt to develop, and especially around the wing inspection plates. While the flaps are in action, the men see that they operate freely, without hesitation or jerky movement. Of course, it won't help that the control surfaces are working now if there's future trouble lurking in a damaged cable. A rag run along the cables will leave telltale lint at any frayed spot. If more than 6 frayed strands are found within an inch, the cable is a villain and must be replaced. Strands are most likely to break where the cables pass over pulleys and through fair leads, and pulleys are turned 1/4 of a turn to spread the wear. Also, they should be checked for misalignment and looseness. And the last operation is to lubricate the cables with rust-preventive compound. Maisie gets this treatment because she's living in a damp climate, a climate which the book calls conducive to corrosion. In a drier area, this operation would be omitted, and the cables would be left dry. To lubricate or not to lubricate is no matter of guesswork or latrine meteorology. The engineering officer has the final say. His word is law. The turnbuckles in the cables are examined to see that they're tight and safetied right. Then, with one hand on the cable and one on the turnbuckle, he sees that the cable is secure in each buckle. The pilot's rudder pedals. Does the whole assembly operate smoothly? Do the pedals fit properly? Any slack or side play? Is everything safetied? Co-pilot's rudder pedals. Are they in good condition? Do they work smoothly? Is everything strictly in order? Now the inspection plate comes off the control column to permit a positive inspection inside of the aileron spur gear chain. This, too, is checked for condition and proper functioning, and it gets a grease treatment with the proper lubricant as specified in you-know-what. Down at the bottom of the control column is a cover boot, which is lifted off after the ring of screws has been removed. This permits a check that the controls have not been fouled and that the column works smoothly. These pulleys, too, are useful all around. Don't let one small segment take all the wear. Then a little movement of the control column, and the pulleys are checked for alignment, freedom of movement, and general condition. Of course, the inspection plate and cover boot go back. And now back in the aft compartment, the rudder is locked with one key and the elevator with another. These two keys, which are not interchangeable, are linked with a chain. The quadrant door is held shut with this pin. The crew chief inspects the data case to look over Maisie's G-file. Are all prescribed items present and accounted for? Are they all in good, readable condition? No pages torn or smeared so as to be illegible. When he's satisfied himself here, the chief's work is done. He calls a meeting of the crew to make all necessary entries in Form 41B and to certify all columns which have been covered in this inspection of the airplane in general. And that initial form is a serious document. It's a bond between the ground crew and the air crew, a guarantee that Maisie is ready to strut her stuff.